All right, we have two integration by parts in here. I just want to do two, not three, not four, because I don't want to make the video too long. So the first one is the integral of x to the fourth ln x dx. So this one, if you already watched the previous video, I let u equals to the x, right? But in this one, I am going to let u equals to ln x. Do you know why? Let me show you why in a minute. And then du equals to 1 over x dx, that is the derivative, right? And then the dv, you are going to let that be x to the fourth dx. And then when you find the v, you have to take integral of that, right? So dx, that is equals to 1 over 5 x to the fifth. Okay, so the reason that you don't let the dv be the ln x is because you do not know this formula. You do not know the integral of ln x dx. What is the integral of ln x dx? So if you look up this online, yes, you can find what that equals to, but when I teach my integral calculus class, I always tell my student that you don't know what that equals to. So this is something that you have to avoid, finding the integral of ln x dx. This one you can use integration by parts to find out what that equals to, but at this point, at the time we are discussing this problem, you do not know the integral of ln x dx. All right, so we have to avoid that. And this problem is completely doable if you avoid finding the integral of ln x dx. All right, so let's go back to the problem. So the next step is we have to do uv minus the integral of v du. So we have to put these four pieces together. So let me give you a suggestion. Please put these four pieces in this order. U du, and then another column, dv and v. So that the v looks like the u. So let me fix that for you. So this is supposed to be dvv. Let's put this in this style. All right. So don't do this in 4 lines. Don't do this in 5 lines. Do this in 2 columns. U du and then dvv. All right. So and then you do uv. So the u times v, that is ln x divided by 5 x to the fifth minus the integral of v du. So 1/5 x to the fifth du is 1 over x dx. And then that is x to the fourth, right? So that is equals to ln x divided by 5 x to the fifth, and then the 1/5 is over there, and then you are finding the integral of x to the fourth. Let's just write this out, the integral of x to the fourth dx, and then this is ln x divided by 5 x to the fifth. And then what else do we have? We have negative, this is x to the 5, right? And then that produce a 1/5 in here, and then this is another 1/5, and then you add c to it. So overall, that is ln x over 5 x to the fifth minus 1 over 25 x to the fifth, and then plus c. So this is the final answer to this problem. And then what about the next one? So the next one, we have x and cosecant square x. So this one, we are going to let u equals to x, and then du equals to dx. So now there is no more x when you find the integral of v du. And then this one, since we know what the integral of cosecant is, in case you don't remember this, let me quickly review this for you. So the derivative of cotangent, is equals to negative cosecant square x. All right, we are going to use this in a minute. So the dv is the leftover cosecant square x dx, and when you find the v, you are going to take the integral of that cosecant square x. So that means you are trying to undo this derivative, right? So that is equals to cotangent, but there is a negative in front of the cotangent, because if you look at the differentiation formula, there is a negative in front of the cosecant square. So that negative will carry over here, so you have a negative cotangent x. And then you put all four pieces together by doing uv minus the integral of v du. I write this out every single time to remind myself what the formula is. So when I take an exam, I don't have to use my cheat sheet or note card. And then uv, that is negative x times cotangent x. And then we have a minus for the formula, and then the integral of v, negative cotangent x. And then when you find the du, so the du is just equals to dx. Look at this piece. So u equals to x. When you find du, you have a dx, right? So there is no more x to take care in this integral. What if that is equals to x squared? Then du is equals to tx. Then there is a 2x. Oh, if, let me say this again. If you let u equals to x squared, suppose that there is a square in the integrand, then du is equals to 2x. Then when you do the integral v du, there is a 2x behind the cotangent. Then that creates a problem, but the problem is solvable. When you have a 2x after the cotangent x, then there is another integration by parts in this integration by parts. And we will discuss that situation in a minute, but not in this video. So that's why you want to let u equals to x, but if there is a x, if that is a x squared, then you have more work to do. If that is x to the third, you have even more work to do. Okay. Now, minus minus, that becomes a plus. So we have x, negative x, cotangent x plus the integral of cotangent x dx. What is the integral of cotangent? The integral of cotangent is equals to ln absolute value of sine x. The absolute value is not optional because the sine x can be positive or negative. Sine, the range is between positive 1 and negative 1. You cannot guarantee the sine is positive, so therefore you need the absolute value. The absolute value is not optional. When you do your homework online and you miss the absolute value, you lose points. They are not going to give you full credits for that. So don't forget that this absolute value is not optional. And then don't forget negative x and then cosine x. So this is the answer to problem number 2. So that is the end of this video. If you think my instruction is helpful, give me a like to the video, leave me a comment below, subscribe to my channel if you haven't done so. Appreciate your help and support. See you all in the next video. Signing off for now.